In this video, we're going to talk about the definition of a parabola. So first off, the graph of a quadratic is called a parabola. A parabola is formed by all points equidistant from the directrix and the focus. So looking at my example, my drawing here, you have a directrix, which is a line, and a focus, which is a point. And a parabola are all of the points that are equidistant, or an equal distance from this point and this line. Now, the midpoint between the focus and the directrix is the vertex of my parabola, and that's going to be important when we are actually using focus and directrix to solve problems. So I want you to note that the axis of symmetry is perpendicular to the directrix. Now, the general or standard form of a quadratic is ax squared plus bx plus c. The vertex form is y equals a times the quantity x minus h squared plus k, where h and k is the vertex. With the focus and directrix equation, it's very much like the vertex, because when we're given a focus and directrix, we're trying to find the vertex to put our equation into vertex form. However, the distance the vertex is from the focus or the directrix is explained as a value of p. And we use that value of p to come up with the a coefficient from vertex form, but we use the constant 1 over 4 and then times p. So this equation here is extremely important when we are trying to find the equations of a parabola given the focus and directrix. So let's look at what that looks like. So using the focus and directrix, given the focus 0, negative 3, and the directrix y equals 3, write the equation of the parabola. So first off, we want to make sure we know our general form that we're using for focus and directrix, which was on the previous page. Y equals 1 over 4 times p, x minus h squared plus k. And so the goal here is to find variables p, h, and k and sub them into this general form. So what I would do is draw a quick sketch. This doesn't have to be to scale, this doesn't have to be perfect. It just has to help you find these different values. So my focus is at the point 0, negative 3. And my directrix is at the line y equals 3. So it's important to know that the point, so if you look and find a perpendicular line, so we know that this is the axis of symmetry of our parabola. All right, we can find a point that is on the same line with the focus, and this point here would be 0, 3. And then I want to find the middle point, or the midpoint. Now, in order to do this, you can count up. So 1, 2, 3, 4, 5, 6. I know that I have a distance of 6. Now, to find the middle of that, I would cut that distance in half, which would be 3. So I know my vertex is 3 above my focus or 3 below my directrix, but it's going to be half the total distance. So that half the total distance is my p value. So we've already found our p. We found our vertex here, which is at the point 0, 0. And now, given our vertex and our p distance, we are able to sub these values in to get our equation. So p is 3, h is 0, and k is 0, giving us the equation y equals 1/12 times x squared. So a more complicated example is given the focus at 0, 8 and a directrix. Oh, and before I forget, so that I don't have to delete this video and do a new one for you all, I want us to look at the picture and go ahead and sketch the parabola. And the reason being is, look at the orientation of this parabola. This parabola is in a downward orientation, meaning that I should have a negative leading coefficient. Remember, the directrix and the parabola don't intersect, so wherever your directrix is, your parabola will be facing the opposite direction. It's so important that you know the sign of this equation, because you would be given, if I just left it at 1/12 x squared, then I would be left with a upward parabola. So, now given a focus at 0, 8 and a directrix at 1, let's look at an example of this. We have a focus at 0, 8, and a directrix at 1. So in order to do this, what we're going to do is once again find the total distance. Alright, and my total distance from 1 to 8 is 7. Well, then half that distance would be 3.5. So I know that my p-value is 3.5. So from that I can actually find my vertex. So from 1, I would go up 1, 2, 3, and then 0.5, making my vertex at 0, 4.5. So using my general equation of a parabola, I'm going to sub in the value for p, 3.5, and then x minus, I'm going to sub in the value of h, which in this case is 0, and then the value for k, which is 4.5. And when I simplify this, I get 1 over 14 x squared plus 4.5. And let's double check. The orientation of my parabola is upward facing, so I can leave it as positive. I want us to look at the x value of my focus and the x value of my vertex are always the same, and then the p distance. So if I add the distance to my directrix, I'll get the y value of my vertex.